Okay, let's look at the combined gas law first. Combined gas law is P1 V1 over T1 equals P2 V2 over T2. This equation can be used when there is no change in the number of moles in the system. Okay, it's the combined gas law because it can be used for problems that only involve Boyle's law or Charles' law or Gay-Lussac's law. You know, Boyle's law says P1 V1 equals P2 V2. If you use the combined gas law, for Boyle's law, T is held constant, and so is the number of moles. So if T is constant, that means it doesn't change. So if it was 25, or like say 298 Kelvin here and 298 Kelvin here, it would cancel out. So you can use this type of equation, combined gas law, for Boyle's law, Charles' law, or Gay-Lussac's law problems. Okay, let's look at a problem. 1182 on page 361. It says a weather balloon has a volume of 750 liters when filled with helium at 8 degrees Celsius and a pressure of 380. That's the initial condition of the balloon. It's at a certain volume, temperature, and pressure. So now we're going to change something that would give new conditions. Okay, what's the new volume of the balloon where the pressure is 0.2 atmosphere and the temperature is minus 45 degrees Celsius? Okay, the one thing you know on these kind of problems is that you must have the pressures and the temperatures in the same units for the both conditions. So it said initially that we had V1 750 liters. The temperature was 8 degrees, and in all the gas law problems, you must have temperature in degrees Kelvin. If you ever divide by a zero, you'll know that you can't do that. So you must have it in Kelvin. So we're going to automatically add 273 to all temperatures. Okay, then it said the initial condition you had 380 torr. That's fine. So this is the initial condition of the gas. Now we're going to change the conditions, and we want to know what the new volume is. And they said the new pressure was 0.2 atmosphere. Now the previous pressure was an atmosphere. So one or the other has to change because they got to be in the same units. So I'm going to put this atmosphere into torr, and this is my conversion, 760 torr per 1 atmosphere. So 0.2 times 760 is 152 torr. And then my final temperature is minus 45 degrees Celsius. I'm going to add 273 to get 228 Kelvin. Now here's my equation. All I'm doing is putting these numbers into the equation. And the best way to solve for this equation, see my V2 is what I'm looking for, is to cross multiply. So when I cross multiply this number here times all of this equals this times this. And so that's what I have. I divide both sides by 281 and 152 to show here, and I get 1,521 liters. I know it's in liters because at the very beginning, my initial volume was given in liters, and that's what I used. So liters goes here for V2. Temperatures in Kelvin here, temperatures in Kelvin here. Pressure was initially given torr here, so I'm going to make it torr here. I could also have chosen to keep the atmosphere here and change this to atmosphere by dividing by 760 torr.